Greetings once again. My name is John Gabriel, and this is a new calculus channel. And yes, in a previous video, I began to teach you the theory of functions, and I showed you how using the function 1 over x of the hyperbola, you get the basic algebraic concept of measure or division. It's the same thing. It's the same thing. The word measure in Greek means the same as divide. And I also gave you a link to a free article, okay? This free article here to my free ebook, this Learning the Correct Way, okay? And then I showed you how all these things work with the measurements. Right, so I'm going to do a quick recap now and show you something else, which I haven't ever revealed before, but I'm not showing you everything. I'm just whetting your appetite. That's all. Ready? Okay, let's go. Now, so what we saw last time was this, where the hyperbola tells us that we need 1 of 1 in order to measure 1, right? And if we have 1 of 5, then we need 2/3 of 1.5 to measure 1, okay? Because 2/3 of 1.5 is 1. And if we had a different value, instead of 1 over x, then let's say we had 2, and in this case, we would need 1 of 2 in order to measure 2, or what happened? Or 2 of 1 in order to measure 2, right? Okay, so basically, I showed you how these things work in the previous video. But now, what I'm going to do is I'm going to teach you something completely new. Now, don't worry about that for the time being, okay? Putting it out of the way there. Now, what you have in front of you here is the relation between two functions. So I'm not teaching you the same way as your crank mainstream mathematics lecturers and teachers waste your time with laws about functions and craps like that, crap like association and surjectivity and injectivity and bijectivity and all that multiple set theory bullshit. I don't go into that. I tell you the real relationships, ancient Greek style, which is based on learning a number, which is based on my free article. Okay, this one here. Let's just go to it for a second. Let's copy this link. My free ebook. I'm sorry, not free article. My free ebook. You have to study this, by the way. You cannot just read this. It's very, very deep stuff. So you have to study it. Okay? It's not easy. And what it does is it gives you knowledge that you never would have realized. You can get the non-watermark version on Amazon. Okay, so let's get back here now. So now what is the relationship between these two functions, this y is equal to x and the hyperbola, 1 over x? Okay. Well, it's an interesting relationship because multiplication is defined in terms of division. So if we say the hyperbola divided by the straight line, we're going to get interesting results. So first of all, let's see the first result. Now the first result says that when we try to measure x with 1 over x, we get this area, right? Okay. So if you try to measure 1 with 1, or 1 with 1.5 with itself, or whatever, or 2.5 with itself, we get a square, don't we? Do you see that? 3 by 3, a square 3 by 3. Isn't that neat? Okay, so that means that we're saying x divided by 1 over x, which is the same as x squared. Okay, so the second result is this, that we can now say to ourselves, well, is there a function that gives us the square value immediately? Well, yes, there is. Okay, and here it is. Let's put a trace on this thing here. Watch this function. You see that? What is that called, you think? Yeah, that's right. You got it right. That, my dear friends, is your famous parabola. Okay, it's a parabola. And now you know why you can't actually multiply 0 by 0, right? See, let's see what happens here. So we basically take a number and measure it with its reciprocal. So we've got 2 and we were measuring it with a half. That's the same as 2 times 2, which is the same as 2 squared, which gives us the parabola, right? Do you see that? 9, 2, 4. So I'll give you access to this applet so you can play with it. Now, it doesn't work properly on all versions of Windows. Maybe you should just download GeoGebra or something. But if you have Windows 11, you'll have issues, and because you can't run other browsers. So we will not say stupid things like it's a function f which takes x to x divided by 1 over x. Okay, we use the correct concept, which is measure. So what are we saying here? We're saying that we're measuring this line here using this line. Okay, and that gives us the concept of area or the hyperbola. Okay, this guy here, which, by the way, gives us the basis for calculating areas. Okay, in other words, if we wanted the area of a circle, it would basically be half half this radius. So, for example, we take 1 and draw the circle in here, and the proportion of the circle to this square would be 3.14, right? So we basically multiply, uh, we basically take the circumference, which is pi, and multiply it by the radius. So now, I don't know if I said that correctly, but I think that if you think about the things I'm telling you, it'll make sense. You know, when you're a genius, you struggle to say things in a way that everybody can understand. It's like I'm expecting you to catch these concepts immediately, but they're not that easy to catch, to understand. But I'll try and do a little write up for you as well, and I'll give you access to this applet. So we use the correct measure here. We say we're measuring x using its reciprocal 1 over x, which results in a square, an area, quadrature, right? That's where the word quadrature comes from this quad, right? You have a quad, okay? So, so now we've gone from just a simple recap of how we do algebra, right? Measures, simple measures, okay? And we've gone all the way through to measuring one curve with another. Nothing about the bullshit of set theory, surjectivity and injectivity, and all that ultra bullshit of David Hilbert and his moron father, George Cantor. Okay, they were all cranks, by the way. They are all mathematical mainstream cranks, and we don't want to be like them. So this is how the ancient Greeks thought. Okay, the only difference between what I've been showing you here and the ancient Greeks is that the ancient Greeks didn't use placeholders. So I'm using x here as a placeholder. In algebra, we use placeholders. We say y is equal to x and y is equal to 1 over x, but these are all magnitudes, or numbers rather. And of course, thanks to Descartes, we pretend that we can represent the measure of any ratio on the Cartesian plane. Okay, and these are all basically numbers, even if they're approximations. So that's pretty much it. If you're not already subscribed to my channel, this channel here, become a subscriber. You can click join to join my members only, where I sometimes share information I don't share with the public, but then you'll have to pay $4.99 a month. I do need to buy coffee somehow, don't I? I only get a measly social security, so I'm in the poverty level, believe it or not. There are many things I cannot afford to buy thanks to those bastards of the mainstream mathematics community and the ones who have labeled me a crank and given me all sorts of mental diseases. So, attributed all sorts of mental diseases to me. So now what I'm telling you here now are the things that you're not taught because your moronic lecturers do not know these things. They will tell you things like f takes x to some crap, whatever, or you have a mapping, or you have one-to-one correspondence, or some other garbage like that, which is totally irrelevant. Doesn't help you understand the concepts. Doesn't help you understand the area, the distance, the volume, or anything else. Okay. So, till next time, I'm John Gabriel. This is New Calculus Channel. Subscribe and click